Hello, and welcome to my YouTube channel called Statistics from A to Z, Confusing Concepts Clarified. These videos are based on content from my book of the same name, which is published by Wiley. For more information on the book and these videos, please visit statisticsfromatoz.com. This video is the fourth in a playlist on variation in populations. The playlist is also planned to include individual videos on the other concepts shown here. See statisticsfromatoz.com/videos for the latest status of my videos completed and planned. The scope of the book, like most introductory books on statistics, includes first and second semester college statistics. That scope is about statistics in populations. But unlike most other books, my book also includes the statistics and processes which are covered in the black belt level of Six Sigma. So I will also plan to do these additional videos on variation in processes. Standard deviation is a relatively straightforward concept, so there may be less of a need to clarify confusion than for other statistical concepts. Be that as it may, here are 5 keys to understanding the concept of standard deviation. The first key to understanding tells us that standard deviation is probably the most common measure of variation in statistics. It is in the same units as the data. The second KTU says standard deviation is the square root of the variance. The third key says data and distributions are often described by their mean and standard deviation. The fourth key says a standard deviation itself can be used as a unit of measure of variation. The fifth KTU says for both normal and non-normal distributions, each unit of standard deviation corresponds to a given cumulative probability of the data points. And here, on one page, are the keys to understanding the concept of standard deviation. You may wish to pause the video at this point and read them all together. Okay, now let's begin our detailed explanations of each key to understanding. The first KTU says, standard deviation is probably the most common measure of variation in statistics. It is in the same units as the data. First of all, standard deviation is a measure of variation. So what is variation? Variation, which is described in detail in a separate chapter in the book and in a separate video, is a property of a population or distribution or data set. It describes how spread out the data is. There are a number of measures of variation, such as range, variance, and mean absolute deviation. Each of these have their pros and cons, which are described in the book and the video. The next slide shows a table which compares and contrasts several measures of variation. Standard deviation has 2 big advantages as a measure of variation. First, it measures the degree of clustering about the mean. It is an approximation of average distance from the mean. Second, the units of standard deviation are the same as the units of the data. For example, if we are collecting data on household incomes in dollars in a community, we may find that the standard deviation of incomes is $40,000. This is in contrast to the variance, which would be measured in square dollars, which of course is not a useful unit of measure. This table compares and contrasts 5 measures of variation. It is described in detail in the article in the book and in the video, variation, variability, dispersion, spread. As shown in the first row of the table, the effect of very high or very low values, outliers for example, is overly emphasized by the squaring in the variance, but that effect is mitigated in the standard deviation, which is the square root of the variance. Which brings us to KTU number 2. The standard deviation is the square root of the variance. In the numerators of both these formulas for standard deviation, we have the sum of the squared differences or squared deviations from the mean. But the denominators are different. The population standard deviation divides by the population size, uppercase N, but the sample standard deviation divides by the sample size, lowercase n minus 1. This gives us a somewhat larger value for sample standard deviation. How much larger is dependent on the sample size. The n minus 1 adjustment accounts for the fact that small samples will give less accurate estimations of the population or process standard deviation than will large samples. There will be more variation. So standard deviations calculated from small samples will be larger than those calculated from large samples. As the table illustrates, this effect will be more pronounced for smaller samples. For n equals 5, n minus 1 is 20% smaller than n. For n equals 100, it is only 1% smaller. KTU number 3 says, data and distributions are often described by their mean and standard deviation. There are 3 categories of measurements which are used to describe data and distributions. For the category of central tendency or center, the most common measurements are mean, mode, and median. For the category of variation, common measurements include standard deviation, variance, and range. For shape, there is skew and kurtosis, but these are not used much. So describing a data set or a distribution by its mean and its standard deviation usually gives us a good description of the situation. Too often, however, standard deviation in a study is not reported in the popular media, so we're left wondering whether the distribution looks like the one on the left or the one on the right. Key to understanding number 4 says, a standard deviation itself can be used as a unit of variation. For example, one might say, this data point is 1.5 standard deviations from the mean. Units of standard deviations are used in the empirical rule and in Chebyshev's theorem, which are discussed in the next KTU. Key to understanding number 5 says, for both normal and non-normal distributions, each unit of standard deviation corresponds to a given cumulative probability of the data points. For normal distributions, we have the empirical rule, also known as the 68, 95, 99.7 rule. In this graph, an area under the curve calculates the cumulative probabilities of all points in the range of values under that part of the curve. For a normal distribution, we can see that 68% of the total area under the curve is above the range, which goes from -1 to +1 standard deviations away from the mean of 0. 95% of the area under the curve is from -2 to +2 standard deviations, and 99.7% of the area under the curve is from -3 to +3 standard deviations. The empirical rule applies to normal distributions. For non-normal distributions, Chebyshev's theorem can be used. Actually, Chebyshev's theorem also applies to normal distributions, but the empirical rule provides more precision for normal distributions. Chebyshev's theorem says that no matter the distribution, 75% of data values are within 2 standard deviations from the mean, 88.9% are within 3 standard deviations, and 93.7% are within 4 standard deviations. And here is the underlying formula which calculates the percentages. Okay, that concludes our clarification of the concept of standard deviation. If you liked this video, please remember to press the thumbs up like button on your screen below. I'll be making more videos of some or most of the 60+ concepts in the book if folks like you tell me more videos are wanted. Please subscribe to this channel to be notified when new videos are uploaded. Also, the website statisticsfromatoz.com has a listing of available and planned videos. Now, videos like this one can be very helpful, but they're not very handy when you want to quickly look up something on the job while studying or during an open book exam. For that, nothing beats a book or an ebook. You can also learn more about those on the website. I'd recommend following my blog at statisticsfromatoz.com/blog. I've got some things there that hopefully you will find interesting, like a Statistics Tip of the Week series, as well as posts showing that you are not alone if you're confused by statistics. I'll also be posting on the Facebook page, Statistics from A to Z, and on Twitter as @StatsA to Z.